Hello everyone, this is Qian. Together with David, George, and Fraser from Autodesk Research, we're glad to present our work TimeTunnel, which is an animation interface that integrates spatial and temporal motion editing for character animation in VR. So over the past few years, VR has enabled users to edit 3D poses by directly manipulating the 3D joints with controllers and hand tracking. It brings opportunity for novices to engage in 3D animation authoring. Recently, we also see applications like Flipside and Mindshow VR that support motion capture in VR to create animations, making it easy to edit motion immediately after being captured. Although these immersive animation tools show promise, most of them still leverage the keyframes and animation curves, which is a legacy design from desktop animation software. In the desktop interface, users typically need to alternate between the 3D model and timeline editor to apply the changes, which could be difficult for novices to learn. And we've seen this similar separation of timeline and 3D model in many existing immersive animation tools. It requires users to mentally keep track of the temporal context and understand how these changes made in the current frame will affect adjacent frames. So the question here is how we can address the separation between the spatial and temporal control and make it easier to edit character animation in VR. Taking a classic graphic editor with the character model as an example, it has a keyframes and animation frames. Each dimension of a joint's position or rotation is represented here as an animation curve, with keyframes connecting different time steps for the curve. While the keyframes are shown as a number here on the curve, each of them also corresponds to a character pose that varies in time. So, can we find a visual representation that integrates the spatial and temporal control to provide an approachable editing experience for character animations? To address this challenge, we create TimeTunnel. It works as follows. An individual frame on this TimeTunnel is then situated on a timeline. The system then uses representative KeyPoses and overlays a trajectory to show the motion. By doing that, time is represented in space, so that the user can then use direct manipulation to pose a character into a new position, and having those changes propagated across all frames between those two KeyPoses. So there are two primary components in this interface. One is trajectory, the other is KeyPose. Trajectory is a set of ordered position of a joint over time. This is different from the motion path, which renders a joint's 3D position in the scene. And the trajectory can then be considered as a stretched motion path over time. It maps time over a lateral axis and therefore provides a view that disentangle potential overlap between the positions. This design brings some level of explanation to the motion but may not provide the full picture. For animations, it's often those representative poses that really matter to control the motion and make the visual explainable. Therefore, we introduce KeyPoses for better explainability. KeyPoses are a set of representative poses that the system computes to show the motion in a concise view. You can consider each keypose as a consolidation of a keyframe on a curve. The system computes the keyposes based on the extreme points on the trajectory, such as the highest point on the curve. When multiple trajectories are considered, joints that have greater movement will have a larger impact on the detection of keyposes. In this example, foot will be more influential than the hand to determine where the keyposes will be. KeyPoses can also be used to define the boundaries so that moving a joint only influences a finite range of frames. By default, it is bounded by the adjacent KeyPoses from the current frame. User can also select different KeyPoses, shown here as a colored figure, so that they can define the range of the motion that they would like their edit to apply. So in this case, you can consider using the KeyPoses to segment the motion in a meaningful way. This allows the user to select a pair of KeyPoses to speed up a segment, or in this case, slow down the motion in between. Next, we implemented 3 scenarios to demonstrate some of the capabilities of the TimeTunnel. The first scenario shows how TimeTunnel can be used to fix motion artifacts. In this case, the character's arm penetrates through the character's body. By making small adjustments, the changes propagate to adjacent frames and therefore remove this occlusion between the hand and the body. Next, we show how we might support object contact. In this clip, the character is supposed to kick a ball, but it fails to hit it. And the user can then adjust the position of the foot, or they can make other changes so that the character kicks the ball, but also maybe look at the ball. Finally, we show how TimeTunnel can be used to apply animation principles, in this case, anticipation and easing. Here we see the character jumping. To exaggerate the motion and create anticipation, the user can manipulate the pose so that it crouches further down. They can also speed up the jump by selecting the key poses with a segment in between contains the jump. Finally, we evaluated TimeTunnel in 2 user studies. This includes a quantitative study with 12 novice users and also a qualitative study with 5 domain experts, followed by interview. In the first study, the goal is then to evaluate the effectiveness of the key components, which are trajectory and KeyPose, in supporting motion editing for novice users. In this study, we then compared 4 conditions as KeyPose and trajectory, KeyPose only, trajectory only, and also a baseline without them. This study then includes a pose searching task in which participants are given a target pose and they need to find a pose in the timeline and submit the right answer. And also we use a pose manipulation task where participants have to manipulate the character so that it avoids all the obstacle. In the pose searching task, we measure time, number of operations, and error. We found that the key pose did not appear to speed up the searching process, but rather it reduced the number of operations required to find the target pose, also with fewer mistakes. In the manipulation task with key pose, participants were able to edit the motion faster, also with fewer frames required to achieve the final results. In the second study, we then provided 5 domain experts with a carbon prototype and conducted a semi-structured interview to explore the strength and limitation of using TimeTunnel for motion editing. From the interview, all experts mentioned that the directness and simplicity as a strength of this interface. They pointed out that working on the joints with overlay trajectory and KeyPose allows them to edit the motion directly than working through the traditional keyframes and animation curves. They also expressed challenges for precise control of editing and also the visual cluttering. The visual space within the tunnel can become cluttered when multiple trajectories are turned on in the interface. Overall, we found that TimeTunnel could simplify motion editing for novices, highlighting the direct representation of motion. It provides an approachable way to edit character animation by integrating space and time and leveraging visual cues that support direct manipulation. This approach complements existing tools and supports a variety of animation contexts, including motion capture data, and therefore enabling new animation workflows.